And go ahead.
Okay, so where your least favorite subject came from? Yay! By Sartok, Mackenzie, Chloe, and Regina.
So math in the Islam world.
Alright, so we're gonna have a surprise in the end. It's gonna be a game, and there will be candy, so remember your facts.
Okay. Islam stereotypes suggest that Islam is all about war and terrorism, and it's just like a major battleground. But the history we learned contradicts this fact and proves that math came here and is useful.
Okay, so I did the historical background. So basically, in AD 622, Muhammad, this is a momentous time in history because this is where Muhammad fled from Mecca and took refuge in Yathrib, which is now Medina. And so he incurred the wrath of pilgrims who had worship to Kaaba Data, which was dedicated to gods. And so he started a monotheistic faith from the Archangel Gabriel. And so this was a very rapid expansion for two reasons. So one of them was for the interest in it of believing in different gods, and then another one was just how much easier it was. And so the Persian astronomy was due to three reasons. One of them was the Syriac astronomy, which was inspired by Hellenistic influence in Ptolemy, and then pre-Sasanian astrology, going back to Babylon astronomy, which was very far back. And then there was Indian astronomy transmitted to Central Asia. And so this happened around 1st and 2nd centuries AD. And then the Arabic language in manuscripts was translated by a very well-known translator. His name was Thabit Ibn Oro, and he was really good at translating, and then also he had much to do with the creation of geometry and algebra. And then here is a picture of how much it spread, and then here is the times it did, and even over here near the Indonesia area.
To understand where the mass come from, there's a very important person that we have to mention is Al-Khwarizmi. Here's a picture of it, and this person find ways and how them of solving math problems called algebra, which is the algebra that we learned last year, and he published the first math book called 200 years ago. He was the person who made possible the math that we use today, and he also he first appears in history as the role of an instructor in an Islamic learning institute called Baghdad House of Wisdom. It's basically a place where gather many smart genius people who trying to figure out many math and scientific problems. And he also studied on geometry and astronomy. He published a really famous book, geography book called The Face of the Earth. And he also persuaded the Islamic leaders to publish a calculation textbook for the public, basically teach them how to do the simple multiplication and addition, things like that. And he's also the one who invented numbers that we use today, because I think most people think Arabic numbers are from Arab, but it's actually from Persian, because this guy is a Persian.
Even before Islamic rule, Indian numerals were spreading westwards due to Indian astronomy. In 773, Indian numerals were spread to Baghdad, which is this. Around 825, Al-Khwarizmi wrote a famous book called the Book of Addition, which is this, and this is Al-Khwarizmi. Many other writers referred to the Indian numerals just like Al-Khwarizmi, and Fibonacci was introduced to the Indian numerals by his Muslim professor. He traveled extensively throughout all of Europe, and he wrote the 9 numerals like this. He wrote them backwards originally. Through his work, Indian numerals became very common in Christian Europe, and in Florence, they banned the numbers because they were too simple. Arithmetic in the Islamic world. The first arithmetic sequence was found by Al-Khwarizmi's arithmetic. They introduced the lattice method, which is historically significant because to this day we still use it in around the 2nd or 3rd grade. Decimal fractions came in the Islamic world in the book of chapters on Indian arithmetics and became important in the Islamic world and outside the Islamic world, especially in the Turkish world. So Regina's going to show you how the lattice method works.
Okay, so you take any numbers between 10 and 99. So we'll do 22 and 53. And so basically, you're just going to create 4 boxes, and you're going to put a line going diagonally through each of them. And so 2 times 5, 10.
10. Thanks, Shelly.
2 times 3,
6.
and then 2 times 5,
10.
2 times 3.
6.
And so per the diagonal boxes, you add them up. So we got 6, 6, 1, 1. And so then your answer would be 1,166. It's super simple, and this is probably one of the first ways that people learned how to multiply. Remember this.
So, math played a big part in the law of Islam. And so there were a lot of laws involving fractions about when a family member died. And when a woman dies, a husband receives 1/4 of the estate or the money, and then the rest goes to the children. But it gets complicated because the rest of the money goes to the children if it's all daughters, and the son receives twice as much as the daughters do. And it's different rules for family members versus strangers, because a stranger cannot receive more than 1/3 of the estate. But some family members choose not to inherit the money or the estate, and that makes it even more complicated. When this happens, the family members that do inherit the money have to give more money to the stranger that would like the estate. Al-Khwarizmi had an impact on the founding of European algebra because it started in Islam and then moved more towards Europe, and he was like the founder of algebra specifically. Abu Kamil is another mathematician, and his work influenced Fibonacci, and Fibonacci went on to make an impact in medieval European math. And there was a third mathematician who had an impact on European math, but he's not well known because this mathematician had more geometric theories rather than algebraic. Algebra moved more towards the west, and Al-Khwarizmi's work was translated, and this had a huge impact on Europe because it was originally in Latin, but then it was translated so people would be able to understand it. And Fibonacci was really inspired by this work after Al-Khwarizmi's work after it was translated. And Arabic professors and manuscripts were prominent in Europe, and many professors came over to work in European universities, and they were just fascinated by the understanding and the culture of the math.
Finally, a conclusion of the contribution of Islamic mathematics. First, they transmitted mathematics to the Western Europe, and then Christians kind of improved it in terms to the math that we learn today. And they also combine algebra and geometry together. For example, this graph here is a quadratic function that I believe all you guys learned. So they combined algebra and geometry together to form a graph to let people understand better of algebra. They also bring together two different mathematical strengths, the algebraic and arithmetic. So it's basically like adding numbers, we're adding two letters. And here I will show you guys a way that algorithmically to figure out to solve a quadratic equation. So if anyone wants to have a try to answer this question,
Go ahead.
so we have x squared plus 10x equal 39. Want to do this problem?
Tell her the next step.
Do you know how to complete square? Ryan? Is there anyone want to try?
We're both
Like you find the square root of x squared and do 39. Close. No, is that wrong? Yes. Okay.
Do you guys remember how to complete the square? No.
No.
Okay. Okay,
Yeah,
I believe the teachers tell you how
Go
to do
ahead, show
that.
them how.
So here we have a plus b squared equal a squared plus 2ab plus b squared. Remember that?
Yeah.
Oh. Okay, so we want to know the answer of x, so we can do a square here with the length of x. So the area of it is x squared, right? So it's x squared, and you want to divide it into 2, so it's gonna be 5x, and you add 5 here. The length of it is 5, so the area of it is 5x, and you want another here. So what is the length of this? 5, right? And you just simply complete the square. And the area of the big square is 25. So what you want to do is x squared plus 10x plus 25 equal 39. And x plus 5 squared equal 39. And now you know how to solve it.
Yay.
Do you guys understand it?
Yeah.
Okay.
Now we have a game for starters. Yeah, time to play Jeopardy.
Alright, so let's divide like the classroom into 2 halves.